In this video, we are going to discuss elimination reaction of haloalkanes. Beta elimination is the second type of reactions of haloalkanes. We are going to take an example to understand what is beta elimination. Let us draw the structure of an alkyl halide. This compound is propyl chloride. This is the common name of this compound, and the IUPAC name of this compound would be 1-chloropropane. We are going to treat this compound with a base. The role of the base is going to be abstraction of proton or acidic hydrogen atom. And when we label these carbon atoms as alpha and beta and gamma, chlorine is attached to alpha carbon atom and it is pulling the electron density towards itself, and which on further the carbons are pulling the electron density of other carbons. Thus, due to this phenomenon of inductive effect, minus I effect, the hydrogen atoms become acidic. These hydrogen atoms become acidic, and we are going to remove them with the help of an organic base like potassium hydroxide. Let me write this structure once again in an open formula so that it is easy to understand. This hydrogen atom is called as beta hydrogen atom because it's attached to beta carbon atom. Beta is nothing but your second carbon atom. This is acidic, and if we talk about the base, it will just pull out the hydrogen atoms as H plus, and the hydrogen gives its electron pair back, a double bond is formed, and hence the carbon breaks its old bond with Cl, and the Cl minus goes out as a very good leaving group. So the products formed would be CH3CH. This H has gone, so a double bond is created here, double bond CH2, and the byproduct Cl minus. Now also we know that H plus was going out in the beginning, so the byproduct is H plus Cl minus, that is HCl. So that was the reaction. Now the base which we can use, as I told you, can be alcoholic potassium hydroxide or sodium hydroxide. During these reactions, that is beta elimination reactions, we should remember that the beta hydrogen atom gets removed and we get the formation of an alkene. Now how is this going to happen? It will happen in such a way that the more substituted alkene should be formed as the major product. So what we have done right now is removal of beta hydrogen atom. How to predict the major and minor products? So here we are going to understand one important rule. The second example which we are going to take is this compound 2-chlorobutane. This is alpha carbon atom, the one which is bearing the functional group, that is chlorine. This is beta. This is another beta. So there are two beta carbon atoms in this structure. First we have to understand where are the beta carbon atoms. Now let us understand how many beta hydrogens can you see. So 5 beta hydrogen atoms I can see, and are they all different? So here we can see that there are two types of beta hydrogen atoms. CH3 is one type and that CH2 is another type. So total two types of beta hydrogen atoms, and hence two products would be formed. How are we going to write down the answer is by using the rule in such a way that the more stable alkene is formed. The alkene which is more substituted is called as the more stable alkene. And why is it more stable? Because of the phenomenon of hyperconjugation. We've already studied about hyperconjugation in class 11th. Hyperconjugation is also known as no bond resonance. Right, so this is your statement which we have written. Now this can be called as a very important rule, that during the beta elimination, more substituted alkene should be formed as the major product, and this very rule which is followed is called as Sedzev's rule. So remember, now I will label these hydrogens as A and B because there are two types of hydrogens. And how will I remove the HCl? There are two ways. Treat them with alcoholic KOH and heat it. There are two hydrogens which I can remove. If I remove the first hydrogen, that is A, I will remove it like this so that the hydrogen releases its electron pair and a double bond is formed, and the Cl minus will go out as the leaving group. The product's structure would be CH3CH2 CH, a double bond is formed here, CH2. So that is my first compound, but-1-ene. The second probability is that the B hydrogen can go out. If the B hydrogen goes out and forms a double bond and the Cl minus goes out, the product would be CH. So this is your but-2-ene. Let's talk about how many substituents are attached here. So this is my major product, that's my minor product, because but-2-ene is a more substituted alkene. If you see the C double bond C, we'll circle the C double bond C and see how many carbons are attached to C double bond C. 1 carbon and 1 carbon. So this will be a di-substituted alkene because the double bonded carbons are attached to 2 carbons. And the top alkene is a mono-substituted alkene. This famous rule is called as Sedzev's rule. Okay, let us see this rule now properly. What is Sedzev's rule? In short, we can say that during beta elimination reaction, more substituted alkene is formed as the major product. So you may remember this for your exam. S for Sedzev's, S for substituted. So it's very easy to memorize. Let us take a good example over here. I have got a compound with a cyclic structure and I'm going to treat this with the base alcoholic KOH and heating it. First, let us see how many types of carbon atoms are there. This is alpha, this is beta, and this is also beta. So if there are 3 beta carbon atoms, but are all of them same or are all of them different? If you see, so you'll analyze that this and this are more or less the same only. They're same because this is attached to one C and this is also attached to that same carbon. So the environment of both the carbons is same. So there are only 2 types of beta carbon atoms. And therefore there are 2 types of products which I can make. One will be the major and one will be the minor. Major will be the more substituted and minor will be the less substituted. So that's the rule. Let us remove the H plus. I'll just draw the H, 3H over here first. Here also there are 2H. One more. Now we are going to label them first as A and B, so that it becomes easy for us to understand. If A goes out, what is the product? If B goes out, what is the product? So this is my B. So A and B are the two different types of beta hydrogen atoms, and hence there are two probabilities of getting the answers. Probability A and B. Now let's take the A. If this hydrogen goes out without its electron pair, and the Cl minus goes out from alpha carbon atom, the product would be, there's a double bond coming here, okay. Now we will see the second probability, that is when the beta hydrogen goes out, the B hydrogen goes out, then we are going to get a product which would look like this. Look at that. Now which one is the major and which one is the minor? Let's see how many substituents are attached here. Okay, we'll just circle them. So here, how many substituents? 1, 2. So this is a di-substituted alkene. And look at this. It has got 1 carbon here, second, 1, 2, and third. This is going to be tri-substituted alkene. So definitely a tri-substituted alkene is the major product, and this is the minor product. Alright, let's take one more example. Now this one is a straight chain compound with different carbon atoms. Let us label first the alpha carbon atom. The alpha carbon atom is the carbon which bears the functional group. Please remember that. Okay. So the reaction is beta elimination. Now here the alpha, the beta, and the beta. There are 3 beta carbon atoms, but if you see carefully, 2 of the CH3s are of the same type. Hence, there are only this one and this one is same. So I can say this one is only one type and this is the second type. So there are total 2 types of beta carbon atoms, there are 2 types of beta hydrogen atoms, and therefore there are only 2 products which I can make. Again the same way we are going to do the product prediction. A and B, we'll just knock out without showing arrow movement, knock out the H plus, knock out the Cl minus, and write the structure. So this is the shortest way in which you can write. CH3C, CH3. Draw the structure. In the same manner, the second probability also you can try out by knocking out the H and Cl. This and the Cl. So you'll get this answer. Alright, so we'll just draw this way, double bond is coming here. And the whole structure is drawn very systematically. And now you see which one is the major product. For that we will have to understand by circling them as we have been doing. Circle the C double bond C and then find out. So in the first structure they are attached to 2 different carbon atoms, so it is a di-substituted, the minor product, and the second one is attached to 4 carbon atoms, so it's tetra-substituted, the major product. That's all from this video.